Okay, in this video we're going to improve some of the bounce code that we have and fix some of the bugs along the way. Now, there's a couple of strands to this. First of all, we're going to create a bit of code so that when the ball is halfway through the wall, which currently we just don't detect in the slightest, what it will do is it'll put it to just on top of the wall, squish the ball down and cause it to start the bounce then. Okay. We will also create a new bit of functionality on our add ball so that we can add a ball at a given location. And this is going to be really critical for when you get to a position where you're trying to fix a certain bug. Like, for example, I know currently a lot of people will have the top bounce just not really working. And also we're going to add some dampening to the walls, and that will allow us to, the balls eventually to stop, basically. So the first thing is we're going to create a new add ball function, okay? And that add ball function is going to add speed as well as position and diameter. So what I'm going to do is I'm just going to take a copy of this one, okay, as my starting point. And I'm going to add there double new x val and double new y. Did I put a space? I did. Y val. Okay, and then the add ball to position. Currently, we're always having a randomized x and y velocity. You want to change that to be a value that's passed in. So we're going to add those parameters here and set them. Now, before we set them, though, I'm just going to grab a copy of this code and pop it there and there, and then overwrite that with new x val. So our common function for creating the ball, which we call with pos, ironically now is no longer with pos, it's with pos, velocity and diameter. Has to be that now has to be passed in. So this one is now the one we just simply pass it through. And for these other ones, we need to create the random value here. Double u. And then pass them in. Start there. And so we've now still got our add ball where everything is randomized and we create random position, diameter, and velocity. An add ball where just the diameter and the position is given and we create the random velocity, and then add ball where diameter, position, and velocity is given. And then in all those situations, it passes into a common function which puts it all together and adds a random color. Okay, so now with that in place, that allows us to, if we need to create a specific ball, a specific location, moving in a specific direction. Okay, and that's because if you are testing something, having one ball that is going to cause your bounce to happen, so put it to the right, put it at the top, you know, put the ball where you want with the starting velocity you want for it to make sure that within 2 steps it is going to pass your wall, and set off your code, and you can put your breakpoint in them. Right, so now we're going to deal with the squish code. Okay, I'm going to deal with it on the left wall first, should I say. as that's a wall where currently everything just goes straight through. So that is, let me see, bounce off the left, no, yeah, left wall. So if the X position is greater or equal to, I did have that as greater than last time, is if the X position is greater than that and the new X position plus the diameter is less than, great, that's exactly what I want now. What I'm going to do is this, adding the diameter means I'm picking up if it passes the wall entirely. And so if it ends up in the wall, it doesn't get picked up as being a bounce. So what I'm going to do, I'm just going to grab this for a second and I'm going to put it to one side. We're going to use that in a minute because we're going to get rid of that and we're going to detect if it bounces, if it passes the wall in any way. Okay, so this includes in the wall and completely past the wall. And then I'm going to create another if, okay, and in this second if, I'm just going to see has it completely passed the wall, okay, and this is where my normal bounce code will be, okay. So here I'm looking to see is it touched the wall in some way or touched or passed the wall in some way? Yes. Here I'm saying, right, has it completely passed the wall? In which case the bounce code as it was. Else, and this means I'm stuck in the wall. What I want to do is I'm going to create an idea where I'm going to put it on the wall and then I'm going to squish the ball down. Now, in order to squish the ball, I'm going to add two new internal private functions, not functions, bits of data. Squish X and Squish Y. I'm also going to introduce two properties for height and width. Now, what that's going to do is instead of just drawing diameter, I'm going to draw the height and width. But the height and width is mostly just going to be the diameter. It's only going to have a get. And it's going to basically look at the value of squish. So if this is width, so I want squish y. So squish y equals 0, then just return diameter. But if squish y doesn't equal 0, I want to return squish y. Now, as well as returning squish y, I also want to get rid of squish y because I only want to show it in one frame being squished. Okay. Now, if I do return squish y, that's it. The code finishes. But if I clear squish y, then I've got nothing to return. So effectively, I want to back it up. Okay. So I'm going to call it return val equals squish y. Then I'm going to clear squish y. So the next time it goes in here, there's no squish y, and we just show the diameter again. And then lastly, I want to return val. Okay, so I mean, in reality, I'm returning squish y, but I also want to clear squish y out. And then I need a similar one for height, except this time I'm going to use squish x. And everything else changes to squish x. All right, there we go. Now, on my render, I use diameter. So for width, I'm going to use width. Height, I'm going to use height. And most of the time, it's just going to be the same. But when I put the squish in place, now I've got the ability to basically squeeze the ball down. Okay, so what I want to do now for the squish is I want to find the difference between basically the part of the ball that's to the right, in this situation, to the right of the wall. Okay, now the way I do that is I take the diameter of the ball and I subtract the other side of it. I subtract what's to the left of the wall. And the way I do that is I subtract the wall's x position from the ball's x position. Okay, so squish y is equal to diameter minus wall dot x pos minus wall dot y pos wall dot new expose. Sorry, I went off a complete strange idea there. And there's something else I need to do here. Oh yeah, now I need to set the new Y pulse. So sorry, new X pulse. I want to set the X, now when I set the squish Y, which uses the X pulse, I want to set the X pulse of the ball to be the wall +1. Happy days. Right, so when you look at this, you might have looked at it and noticed a lot of these were Ys. When I'd done this, I forgot to change a lot of the Ys to X's. And I fixed it off camera. So if you're looking at yours and thinking, oh, hang on, why are both these all X's? Because we're now bouncing off vertical walls, is all the X's that we're changing. The only Y's we should see here is this point where we're checking to see if it's in the shadow of the wall. Okay. So that's going off the left wall. Now, left and top tend to follow similar functionality, and right and bottom follows similar functionality. So I'm going to do bottom now, okay? And then once we've got those two in place, it should be a little bit of copy and paste and just change the, the X's and Y's and things like that around to get the rest of it to work, okay? So when I'm going down, okay, currently I'm only picking up if the ball is completely past the wall. And we've seen this before, where if the ball is kind of stuck between it, then it just shows the ball moving through the wall, but it still picks up when it's completely past the wall, okay? So now what we want to do is we want to say if the min x plus the diameter is less than that. So that means this is now going to pick it up if the ball is in the wall. Oh no, I'm in the wrong. I was wondering why I was looking at min x there. That can't be right. So yeah, we're looking at y positions here. So if the y position plus diameter, okay, if the y position plus diameter has passed the wall, okay, that means this will pick it up also if it's in the wall, okay. And again, I'm going to just grab. Oh no, actually, I'll just do the if straight. So now I'm going to see if the y position on its own is past the wall. And I always keep the bounce out, because no matter what, it's always going to bounce whether it squishes or not. So this means it's definitely clear to the wall. And then my else is I need to do my squish. This time's going to be squish X. So, like before, I first of all find the squish X, and this one, I'm just going to need to subtract the wall X position, Y position, from the ball Y position. Nice and easy. However, setting the new Y position is a little trickier. Or no, actually the new Y position should stay exactly where it is, shouldn't it? In fact, we don't need to change the Y position, do we? Because all we're doing is just squished it, so that we're not going to, it's not going to show going through the wall. Okay, in that case, that one's done, nice and easy. So what I'm going to do is I'm going to use that to tell me how I'm doing this one. So I'm going to add diameter here. And then if new X pulse is greater than wall dot X pulse, Sorry, press the wrong button. Press the wrong button. Now what I'm going to do is I need to find my squish. So it's a squish X. And where were we? Okay, so it should be the same as that. So we have the wall.ypos. So yeah, we're going to look at the wall.xpos and subtract the new xpos. So wall.xpos subtract new xpos. And I don't think we need to set the new xpos because it should be, it's not, we've moved it, we've just squished how we're going to draw it. And then, so now we're going to look at this one. And again, in here we have the if, and the if is going to effectively be this. And then I get rid of the diameter from there. And then inside the else, I'm just going to save me going up and down. I'm just going to grab this and pop that there. Okay, except we're going to change the squish X. So the diameter minus the wall ypos minus the new ypos, and then the new ypos equals wall ypos plus 1, and that puts it just on top of the wall, and then obviously the velocity is changed. Now, last thing I'm going to do on this quite mammoth change is I'm going to add to the wall a dampening factor. Okay, so private double dampening, and then I'm going to set a property for it, and then where I set my walls up, this is a bit repetitive. Unfortunately, this is in the ball world. It's a bit repetitive. I'm going to set my damping factor to 0.85. So bottom wall dot dampening equals 0.85. And then I'm just going to copy and paste that into my other 4 walls. Okay, and I'm just going to copy and paste that into my other 4 walls. And then in my bounce, when I inverse it, I'm just going to multiply it by wall dampening. Take a copy of that and pop it there, pop it there, and pop it there. And now, as well as bouncing off the wall, I also want to slow it in the other direction, even though there's no actual change of direction. So I'm going to use times equals, which is same as plus equals, wall dampening. I'm just going to copy that, pop that there, pop it there, pop it there, but now go in and change these ones to the Y, and this one to the Y. I think that should be everything. So let's see if this runs. So a lot of changes put in. So if this all runs in one go, I will be amazed. But what we should now see is hopefully a little bit more stability in the bouncing. And the ball squishing. And eventually the balls should come to a natural rest. Well, I say natural rest, you will get the wobbling ball effect, which you fix by eventually saying if you get below a certain amount, just stop it running. And you can see, I definitely saw squishing. Oh, what happened there? Okay, some interesting artifacting going on there. Let's chuck some more balls in and see if it's helping on the other side. And yeah, we are seeing them slow down, but there's something odd is happening, which is causing the balls to eventually slowly go down. I know what that is. I didn't change the position, but I knew I needed to change the position here. So the new X position is just going to be the new X position plus, no, minus. I can just do minus minus because I just want it to decrement so that it stood one off the wall. I think that should do it. And similarly up here, new X position minus minus. Hopefully that will stop that slow contraction of the ball. If this quick fix doesn't work, I'm going to do it in the next video, as this one's nearly 20 minutes long already. No, that didn't fix it, so I'm going to fix that one in the next video. All right then.